Hello everybody. Today we are going to see the transportation problem. There are three sources A, B, C and four destinations 1, 2, 3, 4. Each source has got the supply of 25, 35 and 40 units. Similarly, the destinations has got the demand of 20, 30, 35 and 15 units. This table indicates the cost of transporting one unit from one source to one particular destination. That means from A to 1, if you want to transport one unit, the cost is going to be 3 rupees. Similarly, the cost of all the sources and destinations are given. Here, before solving this problem, we have to see whether the supply and demand are matches. So here in this problem, the total supply is 100. The demand is also 100. That means this problem is a balanced problem. If there is unbalanced problem, if the supply and demand is excess, we have to balance this by adding any one row or sources or any one column, that means destination, by adding the zero costs. Now in this problem, let us see how we can solve or effectively transport the supply to the demand or destinations at the least cost method. So here the first one method available is northwest corner rule. In this rule, we have to allocate the supply as well as demand starting from the northwest corner of the table, that means this table, this corner. In this corner, the first destination requires 20 units and then the source is having 25 units. So in this center, we can maximum allocate only 20 units. This can be done by allocating or drawing a small square and allocate the unit here 20 units, and then this destination requirement is satisfied and then the source is having extra 5 units. Now as the column requirement is satisfied, we can move on to the next column. That means we can just move on to this next cell. Now at this cell, the supply is 5 and the demand is 30. So we can allocate mostly the supply of 5 units and then this destination 2 requires 25 more units and then this unit is exhausted. Now since the row requirement is fulfilled, we can just go down. Now in this cell, the demand is 25 and the supply is 35. So here at the maximum we can allocate only 25 units, because by allocating 25 units the total demand of this second destination will be over. Now this will be cancelled and the remaining 10 units is available with the source B. Now since the column requirement is satisfied, we can move on to the next column. Now at this unit, the demand is 35, supply is 10. So here we can allocate only 10 units so that the source supply is exhausted and then the demand is 25 units. Now since the row requirement is completely fulfilled, we can go down in the next row. Here at this cell, the demand is 25 and then the supply is 40. So here we can allocate 25 units for this cell and then this will be exhausted. Here there is only 15 units remaining. Now naturally in the last cell, all the 15 units will be allocated. There is 15 units here and this will be cancelled and this also will be cancelled. So this is one of the possible allocation of the supply as well as demand without violating any norms. So this solution may be optimum or may not be optimum. Presently, this solution is called initial basic feasible solution. Now the cost of transportation will be 3 into 25. That is 3 units, 20 units are transported at the cost of 3 per unit. Similarly, 1 into 5 plus 6 into 25 plus 5 into 10 plus 3 into 25 plus 2 into 15. The total cost comes to 370. This is the total transportation cost by this allocation. This method what we have followed is northwest corner rule, since we have started from the northwest corner of the table. Thank you.